download our Revise It Right revision app for hundreds of videos, quizzes, exam questions, tutor support and so much more. This video is about specific latent heat. Now, heating a substance changes the internal energy of that substance by increasing the energy of its particles. So if we increase something, the energy of the particles will increase. And this has two effects, i.e. the temperature of the substance will increase, or the substance will change state. Remember, when a substance is melting or boiling, we're still providing energy and therefore increasing the internal energy, but the energy is used for breaking the bonds between the particles rather than raising the temperature. So the temperature will not increase if the substance is changing state. Okay, so providing heat to a substance would either raise its temperature or make it change state, i.e. melt it or boil it. That leads us on to talking about something called specific latent heat. Now, the specific latent heat of a substance is the amount of energy required to change the state of 1 kilogram of the substance with no change in temperature. So specific latent heat is the amount of energy required to change the state of 1 kilogram of the substance with no change in temperature. And we really talk about two. We talk about specific latent heat of fusion. Now, this is the amount of energy required to change the state from solid to liquid or vice versa. And specific latent heat of vaporization. And here we're talking about the amount of energy required to change the state of 1 kilogram of the substance from a liquid to a gas, or again, vice versa, gas to a liquid. So specific latent heat is the amount of energy required to change the state of 1 kilogram of the substance. If we're talking about the specific latent heat of fusion, we're talking about that change of state from either a solid to liquid or a liquid to a solid. And specific latent heat of vaporization is how much energy required to change the state from liquid to gas or gas to liquid of 1 kilogram of the substance. Remember to download our Revise It Right revision app, watch over 700 videos, answer 4,000 plus quiz questions, over 1,000 flashcards, 1,000 exam questions, worksheets, forums, and get help from qualified teachers and so much more. The link is in the description. We can calculate this energy by using the following equation. Energy is equal to the mass times the specific latent heat, where E is obviously energy in joules, M stands for the mass in kilograms, and L is the specific latent heat in joules per kilogram. So we can use this equation to either work out the specific latent heat of a substance or calculate the amount of energy required to change its state. Now what I'd like you to have a go at is using this equation to answer these three questions here, and then we'll go through the answer together. So pause the video now. Okay, let's run through the answers then. So in the question 1, we have 5 kilograms of water and it's evaporated at 100 degrees. The latent heat of vaporization of water is 2.26 million joules per kilogram. So therefore, what is the energy for each? So we have to obviously do 5 kilograms times by the specific latent heat to give us 11.3 million joules. So that should have been your answer for question 1. Then we've got 1 kilogram of ice is melting at 0 degrees. the latent heat of fusion of water is 334,000 joules per kilogram. So we've got 1 kilogram, so we do 1 times by the specific latent heat, which is 334,000. So the answer is 334,000 joules. And finally, the boiling point of oxygen is at minus 183. Calculate the energy needed for 50 grams of oxygen to evaporate at its boiling point. The latent heat of vaporization of oxygen is 213,000 joules per kilogram. Well, first we obviously need to convert our 50 grams into kilograms, and we do that by dividing it by 1,000. So we get 0.05. We're going to times that by the specific latent heat, which is 213,000, to get us an answer of 10,650. So we've now learned about what we mean by specific latent heat and the specific latent heat of fusion and vaporization. We have also learned how to apply the equation for specific latent heat. You can now test yourself using the quiz and the exam questions on the topic. If you need any support or need any extra help on any of it, then please do contact one of our tutors who will be happy to help.